Good morning, students. I am Professor Priya Sharma, PC Department, SIRT College, Bhopal. Sage Anandam. So, this is the third lecture of a lecture series of the subject Digital System Design. The third lecture is on adder and the subtractor. So basically, what is an adder? An adder is a digital circuit that performs the additions of numbers. In a processor, it is used to calculate the addresses, table indices, and similar operations. It can be constructed for many numerical representations such as binary coded decimal, that is BCD, or access 3. The most common adders operate on the binary numbers. So there are two types of adders, half adder and a full adder. So coming to the half adder adds two single binary digits A and B and has two outputs, sum and carry. The sum is given as A XOR B and carry is given as A multiplied by B. For half adder design, the logic gates which we require are an XOR gate followed by an AND gate. So this is the circuit diagram of our half adder having two inputs and two outputs, namely sum and cout or carry out. This is our truth table. When the inputs are 0, the sum and carry will be 0. When the inputs are 0, 1, the sum and carry will be 1, 0. When the inputs are 1, 0, the sum and carry outputs will be 1, 0. And when inputs both are high, the sum will be 0, but carry output will be 1. So basically, looking at this truth table, we get that sum output is getting by connecting an XOR gate and carry output is getting by connecting an AND gate. So this is the logic diagram. Now, what is a full adder? It is also a combinational circuit that adds three input bits to generate a sum bit and a carry bit. Here, A, B, and C in are the inputs, and the same sum and the carry out or C out are the outputs. Sum is given as A XOR B XOR C, and C out or the carry output is given as A B bar plus B C bar plus C A bar. We can design a full adder by using two half adders followed by a OR gate. As you can see, we have uses two half adders. One XOR and AND gate will form a half adder and another XOR and AND gate will form another half adder. And combining these two through an OR gate, we'll get the output. So a full adder can be constructed by using two half adders and an OR gate. This is the truth table of the full adder having three inputs and the two outputs. Now coming to subtractor. So what is subtractor? It is an electronic logic circuit for calculating the difference between the two binary numbers which provides the difference and the borrow as the output. Subtractor is also of two types, half subtractor and a full subtractor. So half subtractor is used for subtracting one single binary bit number from another single bit binary number. It has two inputs A and B and the two outputs, namely difference and the borrow. Difference is given as A XOR B, whereas borrow is given as A B bar. To construct a half subtractor using logic gates, we use three gates, that is XOR, inverter, and an AND gate. This is the circuit diagram of an half subtractor having two inputs A and B and two outputs, difference in the borrow. The truth table is given here. When both the inputs are low, the difference and borrow will be 0. When A is low and B is high, the difference will be 1 and the borrow will be 1. When A is 1 and B is 0, the difference will be 1 and borrow will be 0. When both are 1, the difference and borrow will be 0. This is how we logically designed. A and B is passed to an XOR gate to give the output difference. And when A bar and B are passed through an OR gate, we'll get the borrow output. Full subtractor is again a logic circuit which is used for subtracting three single bit binary numbers. It has three inputs A, B, and C in, and two outputs difference and borrow. The difference output is given as A XOR B XOR C, whereas the borrow output is given as A bar B plus A bar C plus BC. Again, we can construct or develop a full subtractor by using two half subtractors as it is denoted and followed by an OR gate. This is the truth table of the full subtractor. Applications of a subtractor are as follows. It is used to attenuate the radio or audio signals. In amplifiers, it is used to reduce the sound distortions. In arithmetic logic units or ALUs of the processors, subtractors are used. Increment, decrement operators uses the subtractor and to calculate the addresses. So that's all for the adders and subtractors video lecture. I hope so it is clear and it is very simple. It is very important from the exam point of view. So please go through it, and all the best, very students. Work hard. Say Janandam.